Welcome to all. Today means this class, numerical examples for design of shear reinforcement for beams in the form of vertical stirrups. Previous part 1, I have given procedure. So many examples I have given. I told correct concept and also for our easy understanding, some financial matter also I told. Just purpose is what? To make clear. Now, I will not tell those things all now. One more thing. See, there will be 4 classes here. Design with only vertical stirrups. 1 class for procedure, already uploaded. Second part now, numerical example. 3 problems will be there. Next, once again new heading. Design of shear reinforcement in the form of vertical stirrups when bent up bars or cranked bars are available for resisting shear or as additional shear reinforcement. 1 part for procedure. Second part for numericals. Completely covered. Now, same way I uploaded earlier for working test method. Part 1, part 2, part 3, part 4. So many things are told there. And I told at that time, when you go to limit state method, exactly same procedure. Only change. Shear force corresponding to working load in working test method, shear force corresponding to factored load or factored shear force limit state method. Tau V there, tau V here. There tau V V by BD, here tau V VU by BD. Tau C maximum same. Same means meaning same. Values are changing, table difference. Tau C also same. Based on percentage of tension reinforcement PT provided. Different table. Then shear force resisted by concrete. There VC, here VUC. Shear force for stirrups. There VS, here VUS. Spacing is spacing. IS code maximum permissible same once again. Therefore, if you once again go through those classes earlier for working test method, understand everything correctly, first of all, this much is not required. I can finish both the numerical part in within half an hour first of all. Still I am taking more time. Why? Because limit state is more important. But remember, any explanation you require, sometimes see, I wrote something here. You can see, class. What I tell in the class, you should write if you are serious. Not serious, you know what I will tell. Okay. First, question 1, I written. Today what I am doing is, I am rotating the questions, changing numbers, so that writing effort is lesser. A rectangular section of a RC beam has a width of 230 mm and depth of 500 mm. Cross section considered is subjected to a shear force of 200 kN. And I told very important, cross section considered. Once you tell cross section considered 200 kN, for that cross section you should see what is the tension steel. Okay, this all I told already. Okay, and cross section is considered is subjected to a shear force of 200 kN and has 3 bars of 20 mm diameter in tension zone at effective cover of 50 mm. Now this cover all I am not bothered now. You already know how to calculate D. Okay. Therefore, the cross section considered. See, 1 minute. It is not given whether BM is sagging or hogging. Hardly matters. So you require one of them. I will assume for sagging. Second question, I will give hogging. What do you do? Put AST at the top. Measure D from here. That's all. Okay. Then further, taking M20 concrete and torque steel of grade FP415, design shear reinforcement for the beam in the form of vertical stirrups. Okay, start. Cross section considered, all millimeter, effective cover B. If you are serious, right? Width of the beam or breadth B equal to effective depth D. 500 minus 50. If you want, you can write once again, but don't write. There's a limit. Distance of centroid of tension steel from extreme compression edge, not required. Next, very important. See, cross-sectional area of steel in tension, AST, provided for the cross-section considered. Pi by 4, 20 square into 3, 942.48. concrete M20, steel top FP415. Given shear force for cross section considered is 200 kilonewton. I told very, very important. What? If in a question, if it is given that shear force is so and so, it is understood that it is corresponding to service load or working load. Therefore, be careful. You have to get factored values. It is a criminal offense if you don't do it. Therefore, taking gamma f equal to 1.5 as per IS code, factored shear force for the cross section considered VU equal to 300 kilonewton. I forgot to write one thing. I will dictate here. You write here. This I can remove now. Okay, let it be there. Right here. Required. So that I usually write it. Required. I will dictate. You write. Next time I will write. Required. Required to design shear reinforcement for that considering the cross section given in the form of vertical stirrups when the cross section is subjected to a factored shear force of 300 kilonewton. Sorry, 300 kilonewton. Write the statement. Next time I will write it. Okay, start. What procedure I given? Follow the procedure. Now I won't waste time. As per IS code, nominal shear stress for cross section tau V, VU by BD, VU 300 10 to the power 3 by BD 2.899 Newton per mm square. Class means, if you want you can write, this is the shear stress for the cross section. So cross section should be able to resist this shear stress like your bill. Okay, sufficient. Now refer to IS code table 20. M20 concrete tau C max is 2.8 Newton per mm square. You can write here. Class, if you want you can write tau C max is the maximum limit for shear stress even after providing shear reinforcement. Oh, gone case. So the shear stress of 2.899, you can write here, this is the actual stress. This is the limiting stress for the cross section. For what? Based on concrete, 2.8. Therefore, not safe. I told yesterday money matter all. Think of that one. Not safe. Cross section is to be redesigned. Yes, our question over. Now what I tell personally, write if you want. This I told earlier. How to redesign? You have to change the cross sectional dimensions. Instead of 230 by 500, you may have to go for little higher depth. Usually breadth is not changed. So that the tau V will come below 2.8. Or instead of M20 concrete, you can change over to M25 concrete. If it is M25 concrete, tau C max is M25 3.1. Yes, then it will be safe. If it is heavily unsafe, suppose heavily unsafe, you can change the cross section and also increase the grade of concrete. These all you write. So that you redesign the cross section finally till or when redesign the cross section so that your tau V is not more than tau C maximum. Then proceed further. Somebody will be there, people. Sir, how to proceed further? Wait for some time. This is question 1. Question 1 stopped. It will come next questions. Further questions, your tau V will come less than tau C max. It will come safe. We will proceed further. That way proceed further here also. Because how to redesign, we will not worry in this class. It will be worried only for professional class. In my regular class, I will tell them what to do. Here for you, question is for the given cross section design, you tell sorry, design is not possible. Stop. Over. Now go to question number 2. What I will do is, I will write now, everything is over now, fair copy. Question number 2. After everything is over, I will go to solution for 2. But for that one, I will change the numerical. I will change the numerical and start. And one part, question 1 suddenly stopped. Student academic point of view, good. Why? Work is reduced. Question 2, what will happen is, it will come safe and shear stress will be within the limit of concrete. So shear reinforcement is not required. But the real question, 99% chance for practically or anywhere is when tau v comes more than tau c, that is shear reinforcement to be designed. That is question number 3. If you want, not if you want, question number 3, I will write everything in front of you only. Because if question number 3 is clear, everything is clear. Okay. I'll change it now. Start now. Question 2. I wrote the question here. I changed the numericals, that's all. I don't have to once again read for just waste of the energy. What I told last time question, save actually what I did. I changed the numbers, that's all. Statement all remains same. But one change I made, see, cross section considered is subjected to a factored shear force of 60. So this time they directly told factored shear force. Thank you. Why? That multiplying by 1.5 is not there. It's already given factored. This is only to save that space here. Make a note. If simply shear force given, or if it is given as per service load or working load, without forgetting, you have to multiply by gamma f 1.5 under normal cases and get factored value. Over. Start. Cross section. 300 by 600. One more thing. See, in the successive change of problem, sometimes what happens is, by mistake, see, to make such mistakes, human nature, some number might have slightly interchange. I am careful. In such cases, don't give too much of problem or too much of worry for that one. Note the change and understand the problem. It is not that everything by chance sometime one value may interchange. It happens when I put successive values like this. Otherwise it will not happen. See, suppose I am drawing SFD BMD all or analyzing a frame by any standard method for indeterminate structure, such things will not happen. But here RCC, when I do same type of question repeatedly for understanding better and better, some slight mistake there, mistake means observation mistake, accidental. It is not technical mistake. If it is there, okay. 300 by 600, 3 of 25 torr I told, effective core I maintained same. B, D, AST, M25 this time, FP415 once again. FP500 I want for last question. Reason is there. Okay, given. Last time I told shear force is so and so. Therefore, corresponding to service load, but this time given directly factored shear force, 60 kilonewton. Over. Required to design shear reinforcement in the form of vertical stirrups. If you want, you can write for when the cross section is subjected to factored shear force of 60 kilonewton to make it more clear. Start. Actually, up to here, I should not explain because repetition. See, tau v, what I told little earlier, class I told, shear stress to be resisted, VU by BD 0.364. Table 20, M25 concrete, tau c maximum 3.1. So tau v less than tau c maximum, safe. Right, class means what? Shear stress to be resisted. How much shear stress is allowed for M25 concrete even with shear reinforcement. Therefore, this time it is safe because we want tau v not to be more than tau c maximum, right? Safe. Therefore, continued. See, continued. See the procedure I have given there. Once you get safe, proceed further. Next, you find tau c. That is allowed shear stress for concrete without shear reinforcement. See, working stress method, the word used is permissible shear stress. In limit state, permissible word is not used. You can use allowed. IS code has told design shear stress strength of concrete. Both are same. Okay. For that you require percentage of tension reinforcement provided for cross section considered 100 AST by BD, PT provided. 100 into AST provided by BD will give 0.892 Newton per mm square. Class, just a joke. Offline class, what I do is, I usually write like this and go to next step. After everything is over, I will tell them, now copy fast. But that is earlier, long back. Nowadays, the copying has gone. What people do is immediately they will take phone, take a snapshot and send in the group. Okay. But earlier all, they will copy. I will start walking along the class. I will come to the first person. I will ask him, what is this? Sir, Newton per mm square. What is this one? Percentage. Area by area. How Newton per mm square came? Oh, sorry, sir. I told that is called blind copying. Then I will tell, when you write something, you should know what you are writing. See, in my teaching, if I write something, I know what I am writing. So many people are seen in online. They write bending moment in kilonewton. When they write bending moment, they should know it is a bending moment, moment unit, kilonewton meter. Some people even go to the extent of writing kilonewton per meter. I am helpless. Therefore, class means no unit. Somebody might have commented already. See, he might have shown this class to others. See, KSN, what he has done. Now he will regret. Oh, KSN knew it. Deliberately he has done it. It is a percentage. Okay. Now, refer to IS code table 19, M25 concrete, PT and tau C. These two values you can see for 0.75, 0.57, for 1.64. No. Yes, correct. It is for next question. Therefore, our PT came 0.892. So, interpolate by linear interpolation for 0.892, get tau C 0.610. Rarely in the class, some student will tell, sir, can you please explain linear interpolation? I will tell no. It is primary school level, not even high school level. I will tell them, what is interpolation? Intermediate values with linear variation means when I was in primary school or middle school, I would have done it. I don't require much knowledge. So I told you are engineering student. That much minimum mathematics you should know. Anyway, if you got difficulty, you can refer to my channel where in the playlist you can see mathematical concept class number 3. Class number 3 is meant only for linear interpolation. So thoroughly explained so that somebody in the road will understand. Okay. Now, compare tau V with tau C. Tau V 0.364, tau C 0.610. Class means, right, shear stress to be resisted. Bill 80 rupees. Money in the pocket 100 rupees. Oh, safe. Therefore, shear stress is within the limit of concrete. Shear reinforcement is not required to be designed. However, provide nominal or minimum shear reinforcement at what spacing? Don't waste steel at maximum spacing allowed by IS code. Okay, propose it. Let us provide 2-legged 8-tor vertical stirrups. Now, at maximum permissible spacing as per IS code. Okay, I will continue. Just 1 minute. Checking camera. Okay, no problem. Now, 1 minute. Time being stop. I want this space now to continue. Problem is, you can see question number 2 here. Question number 3, I do not want to waste time by writing once again. So I will do one thing now. Right here. You don't write anything. Wait for some time. Question number 3, I am dictating now. Then I will rub this portion and continue question number 2. That much adjustment is okay. Okay, see, question number 3, I already prepared the question. See, I told I will solve in front of you only. Still, I do not want to waste time every time to use calculator. Suppose one mistake comes there, problem. So, but technically, I will do in front of you. Question number 3, right now. A rectangle section of RC beam has a width of 250 millimeter and depth of 650 millimeter. The cross section considered is subjected to a factored shear force of, where is it? 275 kilonewton, and has 2 bars, and has 2 bars of 25 mm diameter in tension zone at effective cover of 50 millimeter. Okay. Taking M25 concrete and tar steel of grade FE415, Design torque M25 la, taking M, which concrete I taken here? Here M25, correct? M25, taking M30 concrete. Correct, M30, yes, correct, M30. And torque steel of grade FE 500. See, this only I told. By chance, if this little this side, that side is there, don't worry about it. Procedure should be clear. Design shear reinforcement in the form of vertical stirrups. That's the question 3. So, when I come to question 3, see, I will tell now. 250, 650, 2 bars, again, bending moment, I'll assume sagging only. Don't waste time on that one. 2 bars of 25, I'll remove one of the bar. B, D, all I will write here as usual. M30, FE 500, given factored shear force for cross section considered VU equal to 275 kilonewton. Same requirement up to here, and actually up to this step I will not explain. But what will happen in the next question? Your tau E will come more than tau C. So shear reinforcement is required to be designed. Therefore, I already explained question number 3. Now do one thing. I will remove this one. Question number 2, I stopped what? Let us provide 2-legged 8-tor vertical stirrups at maximum permissible spacing as per IS code. I will continue now. I will rub the portion cleanly and then continue. Okay, I told provide at maximum permissible spacing. Go to IS code. Maximum permissible spacing for vertical stirrups is all I explained earlier. 1, 300. Second one, 0.75D. Substitute 0.75 into 550. Last one, ASV into 0.87 FY by 0.4B. FY not to be taken more than 415 as per IS code. Those who want, right? Those who want, ASV is cross-sectional area of legs of the stirrups equal to cross-sectional area of one leg, pi by 4 of 8 square into number of legs. People are knowing it. Into 0.87 into. Our Fy is 415. IS code told you should not take Fy more than 415. Since it is 415, you write, we have to substitute Fy equal to 415 only. Substitute 415, 302.47 will come. Now, 3 values are there. They are the maximum permissible limit. Common sense. Whenever maximum permissible limit is there, you have to always take the least value. In YouTube, one class I am uploading for general public, not for RCC. The maximum minimum confusion I am removing with the technical explanation and also financial matter. Therefore, among the 3, the least value is 300. So let us provide 2-legged 8-tor vertical stirrups at 300 mm center to center. Question 2 over. Over. Okay. Now, practically 300 nobody will agree. They may reduce to 200. Let them do it, or 250. But structural strength point of view or design point of view, 300 okay. Okay, now I will start. Question solution for question 3. Up to some level I will take now. Then I am rubbing everything. Question 3. Width of cross section is how much I told. Just now I given the question for you. I rubbed the question. I told width is 250, I think, correct? Yes, 250. I told overall depth is 650. Question number 3. Tension side I told only 2 bars. AST, it is 2 bars of 25 torque. See, I have not shown you how is the vertical stirrups. If you want, you can write here. One question. How is the vertical stirrups? 2 bars you require at the compression side. This is the vertical stirrups. This is the spacing. Oh, that all practical aspect. It will, you have to learn it later. I am doing structural part. Okay. Now, B 250. B is 250. D is 650. 650 minus 50 is 600 millimeter. AST, pi by 4 of 25 square into 2, 981.75 mm square. This, see, this I am saving time. Concrete, M30, steel, M30, clearly out right. M30 steel, tor of grade, FE 500. A tor of grade, FE 500. factored shear force for cross section is 275 kilonewton or equal to 275 10 to the power 3 Newton required to design shear reinforcement in the form of vertical stirrups. If you want, you can add when the cross section, given cross section is subjected to factored shear force of 275 kilonewton. So multiplying by load factor is not there. We have tau V equal to Vu by Bd. It is 275 10 to the power 3. B is 250. D is 600. You should not do this way. One more fair copy required for you. Where is the answer? Somewhere. 1.833. 1.833 is the stress. For M30 concrete, RCC. Last time I forgot here. Table, no, it is table 20. Okay. Table 20 for M30 concrete. Tau C maximum is, I forgot the tau C maximum. See, I am very weak in remembering values. 3.5. IS code is ready. 3.5 Newton per mm square. Therefore, the shear stress coming is quite high actually. 1.833 is less than tau C max. It is safe. Continue. To get tau C, same way 100 AST by BD, just now explained 100 into 981 point, how much it is? 981.75 divided by 250 divided by 600. The percentage will come 0.655. I won't write Newton per mm square now. Okay. IS code table 19 for M30 concrete. Some will tell how M30 concrete for PT and tau C. Now you require for what? 0.655, for 0.5 and 0.75. For 0.5 it is 0.5 only. 0.50. This is 0.50. Other one is 0.59. Therefore, for PT equal to 0.655, tau C equal to, by interpolation, 0.556. 0.556 Newton m square. Tau V, how much you got tau V? High stress, 1.833. Now tau V is more than tau C. Tau C is here, 0.556. Or the bill is more than how much money in your pocket, but it is not more than that much after your friend will help. Suppose I told you have 100 rupees. Your friend told he will give 200 rupees. First question, bill came more than 300, outrightly unsafe. Second question, bill came less than 100. You only save, no help required. Third question, bill came, say, 225 rupees. You have 100 rupees, so you require another 125 rupees. Yes, your friend can give it because he told I can give up to 200. So 1.833. Here only I told, by chance some number is forgotten means change it. 1.833, correct? Yes, is more than 0.556. Therefore, shear reinforcement is, shear reinforcement is what? Is required. Required to be designed. Okay, up to here, that's all. This is cancelled. I will write fresh. So, shear reinforcement is required to be designed. Okay, now I will tell in front of you step by step. I will write because among these three questions, what I am doing now is the most important. But before I rub everything, I will make a note here so that later no confusion. B, some values are here. One is here. No, I think everything I have noted down everything, not required. See, 1 minute now. Tau C over VUC you require. Yes, VUC is there, VUS is there, spacing is, everything is there. Okay, no problem. Nothing to worry. I will rub everything neatly. I will solve in front of you only. Okay. I will continue. See, just for understanding, actually you can see there. Last step was tau V more than tau C. Shear stress to be resisted is more than the capacity of concrete without shear reinforcement, therefore required. This is explained so many times, technically and also financially also. If still not clear means not worth continuing structural studies. Okay, now continue. Let us provide, I told, propose suitable reinforcement. Usual, popular in India at present. Let us provide 2-legged 8-tor vertical stirrups. You can make a note here. Sometimes when you design, stirrups will come very, very close. It may not be possible. Say, suppose 40, 50, 60 mm means it is not practicable. Then what you can do is either increase the diameter instead of 8-tor, slightly more. Okay, usually 8-tor, rare case 10-tor, worst case 12-tor. And still very heavy force means instead of 2 legs, you can go to 4 legs. There is one more option is there. What shear force you considered, if it is at the face of support and if the support reaction gives compression to the beam, then you can move by distance d and consider little lesser shear force, design shear force. That all comes in the class. Here shear force given. Okay. Now what you have to find? Spacing. See, as per IS code, actually the derived formula, spacing of vertical stirrups. Spacing of vertical stirrups. That is SV equal. Remember, this is strength based. Very, very important. Make a note, strength based. Don't write in this, whatever you spacing you get, you should not provide a spacing more than that one. This is strength based, not nominal spacing. Equal to 0.87 Fy into ASV into D divided by VUS. See, working stress method. Sigma SV into ASV into D divided by VS. That all I told. Start one by one. See, now I will write ASV is cross-sectional area of legs of stirrups. I am writing everything for you. Legs of stirrups equal to pi by 4 of diameter square of the stirrup into number of legs equal to pi by 4 of 8 square into number of leg 2. I know the answer. Everybody knows it. 100.53 mm square. Okay. ASV over. D is already known for you. VUS. VUS is factored shear force. You can call either factored or ultimate. Whatever you want. Ultimate shear force to be resisted by vertical stirrups here. Vertical stirrups. Or actually IS code told by shear reinforcement. See, IS code told instead of vertical stirrups, they told shear reinforcement. Both are same. VUS equal to shear force, factored shear force VU subtract ultimate strength of concrete, where VUC is ultimate shear strength of concrete. Concrete, you can write here without shear reinforcement. Okay, just to make clear, without shear reinforcement. I already told VUC equal to tau C into BD equal to tau C. Where is tau C? Tau C is 0.556 into 250, D is 600. Newton per mm square into mm square will come VUC, where is it? 83.4. It will come 83.4 10 to the power 3 Newton. This much shear force concrete alone can resist. Therefore, your stirrup should be able to resist a shear force of how much? VU. VU is 275 10 to the power 3 minus 83.4 10 to the power 3. Actually, IS code has told you directly VUS equal to VU minus, they are not given VUC, tau CBD directly. But for concept, I am doing this way. Answer is 191.6. 191.6 10 to the power 3 Newton. Now, lastly, as per IS code, Fy is not to be taken more than 415 Newton per millimeter square when you design shear reinforcement. This is for shear reinforcement. Any steel you use, you cannot substitute more than 415. See, for FE 500 grade steel, actually Fy is 500 Newton per mm square. It is 500 Newton per mm square. So for bending all, you take 500. No, but IS code told for shear, you cannot take. Therefore, considering IS code condition of Fy, this much actually not required. Not to be taken more than 415 Newton per mm square. Substitute or consider, that is substitute, consider Fy equal to only 415 Newton per mm square. Okay, start. I'll write here. Substituting spacing SV, remember strength based. It is not some nominal, it is strength based. Means very important. 0.87 into 415 into 100.53 into 600 divided by VUS. Where is it? 191.6 10 to the power 3. Answer will come 113.66. 113.66 millimeter center to center. You can make a note if you want here. See, based on strength, see, I can make a small note here. See, if the 2 bars are here, just nominal 2 bars you can see here. Once you provide one stirrup here, next stirrup, okay, it will turn actually, no problem. Okay, put one more if you want to understand. Continue. Once you provide one stirrup here this way, next stirrup will come here. This spacing as per strength is 113.66 millimeter. Therefore, in case you provide more spacing, beam becomes weak. Required shear strength will not be developed. Suppose you reduce it, okay, it becomes stronger. So make a note here, at any cost, IS code, I told already, safety first, then IS code. Strength first, then IS code. Therefore, now do one thing, make a note here. Make a note. We got spacing based, right here, we got spacing based on strength. But now consider IS code. Because IS code, when they give this formula, strength they are not bothered. So, as per IS code, maximum permissible spacing for vertical steps is 300 millimeter, 0.75D, 0.75 into 600 is 450 millimeter. Last one, ASVFY by 0.4B. This time calculation not required because ASV is known. Again IS code told Fy not to be taken more than 415. Already explained there, equal to 100.53 into 0.87 into 415, not 500, divided by 0.4, divided by width how much? 250. This spacing will come 362.96 millimeter. Among these three, least value once again is 300 millimeter. Now make a note. You should make a note here. See, I will tell a note here. Personal note. Based on strength, see, first of all make a note. Spacing we got based on strength is how much? 113.66 millimeter. Okay, now from strength based we got how much? 113.66 requirement. IS code is telling you should not provide more than 300. Yes, provide 113.66. Therefore, compare these two, take the least, right here, compare the designed strength-based spacing with the maximum limit here, provide whichever is lesser. Those who want, right here. Therefore, conclude, let us provide two-legged 8-tar vertical stirrups at 113.66, odd number. Bar bender will tell, sir, what is sir this? Round off. Rounding off is not higher side. Suppose you got 114.98 also, not 115. Rounding off lesser side, 110 millimeter center. Suppose in the design office is there, if a senior person is there, he will tell, change the 110 to 100. Okay, save. Now make a note here. Sometimes shear force will be quite small, but of course tau is more than tau c, but marginally more. See, for example, you make a note. Suppose here tau c, how much you got? You got tau c equal to, where is the tau c value? 0.556. Your tau e came 1.833. It is very much higher. So we require closed stirrup. That is severe shear. Now, suppose your shear force is lesser. Tau e is only 0.7 or 0.8 for 0.8 or 0.75, like that. No doubt, it is more than capacity of concrete. Shear reinforcement is required. All the steps will come. What will happen is, when you calculate spacing, SV, it may come some 895 millimeter, sometimes even 1250, etc. High number will come. Then what to do? But then IS code told you cannot give more than 300. In such cases, just right here, suppose spacing came 895 millimeter. Just a note, actually question 3 already over there. Okay. Then you cannot give 895. Why? Because IS code is not permitting you to provide spacing of more than 300. So instead of 895, see, strength-based spacing requirement is 895. If you provide 300, IS code is agreeing, beam is happy. Why? It is getting more shear steel. Okay, over. This question is over. Thoroughly study everything. First, if you want to study working stress method, once again, the 4 parts, and limit state also. Now I will take 2 more classes. Both are for design of shear reinforcement in the form of vertical stirrup only, but when cranked bars are available. 1 class for principle and procedure, 2nd class for numerical. Then one last uploading will be how to find ultimate MR for a T-section. So many people would welcome it. It is a little complication is there, especially when neutral axis lies in the web. I have seen so many people making mistake. I will rectify the mistake. Some will tell, what is the guarantee that what you are telling is correct? You ask the people who know about me. Okay. Now this will close. I will upload next 2 more classes for shear. Then last uploading is for ultimate MR calculation of T-section. Then new course will started by me. Not this way random uploading. A course systematically from engineering mechanics. Everything systematic. So that if you start studying from there, nothing is left out. And see how much information I will give for you. And way of talking will be further, clarity will be there. Because this all, I want to first close all this first. So even talking also, I will change the way. So that maybe little slow, but understanding will be very, very clear. And there will be option of collecting notes from me also. I will let you know little later. I will upload a class. Information class I will upload. Just around another 1 week more.